Hi guys, so I am not in class today, so here is a video leading you through our notes for today. So today we are working on finding equivalent ratios. So I'm going to do number 1 with you, number 8 with you, and then number 1 on the back with you. Okay, so 3 different examples of how that can work and how we're going to solve them. So for number 1, we're going to first look at our starting ratio. For every 3 girls, there are 7 boys. So number 1, we've talked about, when we first talked about ratios, we talked about ways that we can write them differently, okay? So we've written them with a colon, right? Like that's a colon with the word to. And then another way would be to write it with or as a fraction. So when we find equivalent ratios, we've been using double number lines, tape diagrams in order to solve it. But the way that we really use it in real life is with the fractions. So we're going to start here. So I'm going to represent this as a fraction. For every 3 girls, so here's 3 girls, there are 7 boys. So 3 to 7, and it's just set up like a fraction, okay? And I want to make sure that I'm labeling this as well. So I have my original ratio, and next I have how many girls are there if there were 175 boys. So now I'm going to set it up like an equivalent fraction, which you guys have been doing since elementary school. So since it's talking about 175 boys, boys is on the bottom, so I'm going to put it on the bottom over here for this one as well. So 175 boys. So now I have to think, well, how do I get from 7 to 175? And I can do that by dividing. So I pull up my calculator and I do 175 divided by 7. So the right number divided by the left number. And you see that my calculator gives me 25. So I know that I did 7 times 25 in order to get 175. And then just like with an equivalent fraction, whatever I do to the bottom or the top, I also have to do to the other piece. So if I multiplied 7 by 25, I also have to multiply 3 by 25. And 3 times 25, if you're unsure, you can use a calculator, but I think of quarters. 25, 50, 75. So it'd be 75 girls. And then I can circle my answer up there to show that's my answer. We also want to make sure that we're using the arrows to show what we multiplied by, and that would count as showing our work, okay? Now, number 8 down at the bottom. So I have pay in dollars to hours, okay? So it gives me actually 2 ratios here, okay? I have 3 hours to $24. Now, hey, here comes unit rate. How much do I get in 1 hour? Well, 3 divided by 3 is 1, so 24 divided by 3 is 8. So it'd be $8 in 1 hour. There's unit rate. So you can find that or just work with the original. Okay? I'm going to work with the unit rate. So now, how many hours would you have to work to receive $96? So dollars is on the bottom, so I have to line up 96 here. So here's $96. Now I can use my calculator. What did I multiply 8 by to get 96? And I can do 96 divided by 8 to get 12. That shows me that I did 8 times 12 to get 96. So I have to do the same thing to the amount of hours. 1 times 12, which gives me 12 hours. And then I can circle my answer there. Now, as a little refresher, it talks about independent, dependent variables and an equation. So independent variable, what's in charge here? Well, I have to know how many hours I'm going to work before I know how much I get paid. So independent variable would be hours. Dependent variable would then be my pay, because I can't go in and say, I'm going to earn $100 today, but I'm only going to work 2 hours. It doesn't work like that. We have to go in and say, I'm going to work for 8 hours. Let me figure out how much I would get paid after that. Okay, then the equation, what am I doing to X? What am I doing to my independent variable in order to get Y? Okay, so now I have to see, what did I do to 3 to get 24? What did I do to 5 to get 40? And you can double check on your calculator. 24 divided by 3, that gives me 8. Let me just check that make sure that it works with the second ratio. 40 divided by 5, that also gives me 8. So I know that for each of these, I had to multiply by 8. So that tells me that my equation would be y equals, we always start our equations like that, y equals 8 times x. And remember, when you have a number next to a variable, that means multiply. All right, last question on the back. Number 1. So, Mr. Tate's class earns points for good behavior. This graph shows how many points need to be earned to trade in for 1 ticket. So now I have a graph. I could pick any ratio on here and start that as my original ratio. So for this example, I'm just going to find the one where it first hits the line with equal numbers. So I have 5 points, and that lines up with 1 ticket. So there's my original ratio that I can use, okay? I could have also used 10 to 2 or 15 to 3. Any of those would work. Now, sorry, I'll move the calculator. How many tickets will a student receive if they get 20 points? So now over here, points is in my numerator, it's on top. So here's 20. So I have to think, what did I do to 5 to get 20? Well, if I'm not sure, I can do on my calculator 20 divided by 5. That would give me 4. So that tells me that I multiplied by 4, 5 times 4 to get 20, which means I have to do the same thing on the bottom. 1 times 4 to get 4 tickets. Circle my answer. Next one. How many points did a student earn if a student received 25 tickets? So set up my original ratio. 5 points gets me 1 ticket. And I have 25 tickets. So how did I get from 1 to 25? Well, I multiplied by 25. So 5 times 25 gives me 125 points. And I would circle that one as my answer. So that's how we find equivalent ratios using setting up ratios like fractions.